Okay, so we're going to be working on, make sure that my mic is working here, we're going to be working on interpreting quadratic models. So we're going to have to try and figure out what things mean. That means we're going to have to read. I keep telling all my students, you have to read. So Ron started a construction company. The net value of the company in thousands of dollars, T months after its creation, is modeled by here. So we have the net value and months. So let's draw it out what that might look like. Yeah, I can see it opens up, and all companies start out in the negative, and then it's going to come up here and it's going to hit there. So what is this? This is time. And what is this? This is money. This is how much they're worth. Okay, their total value, their net value. And so what is it asking for? If a company's net value is $0, the company is breaking even. Ron wants to know how many months it will take for his company to break even. So what he wants is that break even point. Net value is 0, so we want a 0. All right, and there are going to be two zeros. There's going to be 1 0 over here, but we don't want that one. We want the larger one. So rewrite the function in a different form, factor to vertex, where the answer appears as a number in the equation. So we want to find a 0, and we want it to be obvious in the equation. So what does that mean? That means we need factored form. Factored form tells us zeros. We learned that in the last video. So let's go ahead and do that. I'm going to find the 0. So I'm going to set v of t to 0, and I'm going to say 2t squared minus 12t minus 14, and actually that's going to be our vt. We're going to start there. The first thing it wants is a different form. So I am going to put it in this form, bring out this 2 here, t squared minus 6t minus 14, and then we're going to try and factor that. Minus 7. And we're going to try to factor that. And we want two numbers who multiply out to be -7 and who add up to be -6. So numbers that multiply out, factors of -7, there's not really very many, are there? There's -1 and 7, and then there's 1 and -7, and then we're done. So sometimes it's going to be a lot more complicated than that. But these two add up to be -6. So that's what we want. We want 2t plus 1 and t minus 7. There we go. So that's the first thing we're going to write down. We're going to write down that we want it in this form. T plus 1 times t minus 7. There we go. So that's the first thing we want here. And so the question is, how many months after its creation does the company break even? So if we want zeros, then either t plus 1 is 0, so t is -1, or t minus 7 is 0, so t is 7. And that's the number we want right there, which is 7. T minus 1 is 0, so at 7 months it hits 0. Let's look at another one. We've got 4 here. Tom started an entertainment company. The net value, again net value, of the company in thousands of dollars, t months after its creation, is modeled by bing bing. Tom wants to know when his company will be at its lowest net value. So the model again looks like that, but what we want to know is we want to know lowest. Lowest is minimum, okay? And that is about vertex. So we want to put this in vertex form. And it's asking when. So that's the x value. of the vertex form. So rewrite the function in a different form, factor the vertex where the answer appears as a number in the equation. How do we do that normally? We do it by completing the square, right? So v of t is equal to 4t squared minus 24 minus 28. And the first thing I'm going to do is factor out a 4 here. T squared minus 6 minus 7. So this is, oh, shockingly, almost the same. 6x. Almost 6t. Oh my gosh. 6t. Well, that's good. Vt is equal to 4t squared minus 24t minus 28, and then we'll factor out the 4, and we'll get t squared minus 6t minus 7, and that is almost the same thing that we had last time, except there was a 2 up here. Okay, so now I'm going to go ahead and I'm going to work off of this and work on completing the square here. So if we're going to complete the square, I need t squared minus 6t. I need plus something, and over here I have a minus 7. So 6t, I know that I'm going to have to take, this is my b value. I'm going to have to take half my b value, which is negative 6 over 2, and then I'm going to have to square that. So that's going to be negative 3 squared is 9. So I'm going to add 9 here, and then I'm going to have to subtract 9, so I get 0. Okay, so I'm going to end up with t squared plus, minus 6t plus 9 minus 16, and then I'm going to be able to put this into x minus 3 squared minus 16. So now I've got this 4 times x minus 3 squared. I'm going to redistribute this 4 out to the negative 16 minus 64. 4 times negative 16 is minus 64. So there's my vertex form, and it will tell me that it's at 3, x minus 3. So it's at 3. 3 is the minimum value, and then in that case, it's the minimum value is 64. So let's go ahead and write this up over here. Mouse is still not working. 4 times x minus 3 quantity squared minus 64. Okay, and how many months after its creation does the company reach its lowest? That's going to be 3 months. T. Sorry about that. Okay. Put in the wrong variable number, it doesn't count you wrong. I'm lucky there. So, not only did I write the incorrect variable name over in here, I wrote the incorrect variable name over here as well. Awesome, Dan, awesome. So, all right, let's read. Paul opened a bakery. The net value of the bakery in thousands of dollars, T months after its creation, is modeled by. Okay, so we've got this this same formula again. Paul wants to know what his bakery's lowest net value will be. Okay, so last time we wanted to know when was the lowest net value, and this time we want to know what the lowest net value is going to be. So it's going to look like here, and they want to know what the lowest is minimum, so they want to know the y value of the vertex. So again, we should put it into the vertex form. So v of t is equal to 2 times t squared minus 6t minus 7. This is looking really familiar again. Okay. And I'm going to take that out, and then we can do the same thing that we did last time. T squared minus 6t, and then minus 7. We've got plus 9, just like we had last time, and minus 9. So we've got t minus 3 squared minus 16. And I'm going to put this back up into here, and I'm going to distribute out the 2 with the negative 16 here. So we've got 2 times t minus 3 squared minus 32. 2 times negative 16 is negative 32. So this tells us that, again, it's at 3 months, and the lowest value is negative 32. Let's go ahead and type this in. X minus 3 quantity squared minus 32, and then of course we know that the lowest value is negative $32,000. T. Okay. I have to do this video again. Alright, it's been a long day. Okay, last one here. Paige launched a ball using a catapult she built. The height of the ball in meters above ground, t seconds after launch, is modeled by, it's t, Dan. The variable is t. Paige wants to know when the ball will hit the ground. Okay, so let's see if we can kind of draw this out. There's no y-intercept. This is in standard form, and there's no y-intercept. So the y-intercept is 0. It's going to be at 0, 0, and then it's opening down, so it's going to look like this, and it's going to come. So it's going to look kind of like that. Paige wants to know when the ball hit the ground. When does the ball hit the ground? That's one of my big ones. That's when does it end. All right, and that tells us that we want a 0. So if we want a 0, then we want the factored form. So I'll rewrite the function in a different form, factor to vertex, where the answer appears in the equation. So I've got h of t is equal to negative 5 t squared plus 40 t. So now I can factor out, I think I can factor out a negative 5 t here, and I can get t minus 8. So I've got negative 5. Pull a negative 5 out of here, and a negative 5 out of here. Pull the t out. Got t minus 8. So let's go ahead and get that. Negative 5t times t minus 8. So what does that mean? That we know that it hits the ground at 8 what? Seconds. Seconds after launch. Seconds. So it's 8 seconds. So how many seconds after launch does the ball hit the ground? 8 seconds. All right, and except for the fact that I can't remember my variables, that's what we're doing when we interpret quadratic models.